Imagine if you could run so fast that light itself struggled to keep up with you. It's a powerful science fiction kind of thought. Picture it. You take a single step and cross an entire continent. In the time it takes to blink, you could race from the Earth to the Moon and back again. This isn't just about being quick. It's about touching the very fabric of the cosmos. You're not just moving through space. You are challenging the fundamental speed limit of the universe itself. This is the awesome, mind-bending power of the speed of light. So just how fast are we talking about? Light travels at a staggering 299,792 kilometers per second. Let's round that up to a clean 300,000 kilometers, or about 186,000 miles, every single second. A beam of light can circle the Earth more than 7 times in the same second you snap your fingers. It's the universe's ultimate speed limit, a constant Albert Einstein placed at the heart of his theory of relativity. He declared that nothing with mass, a spaceship not a planet, and certainly not a person, can ever reach this speed. It is the law. This cosmic speed limit isn't just an arbitrary number, it's woven into the very structure of space-time. It governs how energy and matter interact, how time flows, and how we perceive distance. Traveling at light speed isn't just point A to point B. It's a state where the familiar rules begin to break down. The universe has put up a firm stop sign. Trying to run past it would change everything. Why is this speed so special? Because light particles, or photons, have no mass. They are pure energy, free to travel unburdened through the cosmic expanse. Everything else, the smallest atom, the largest galaxy, is made of matter. And matter, as we will see, comes with baggage. This distinction is the critical barrier between possible and impossible. What would happen if you, a being of flesh and bone, could somehow accelerate to near the speed of light? The experience would be nothing like a simple jog. First, your personal experience of time would begin to warp. For you, the intrepid runner, time would slow down dramatically. This is not a trick. It's time dilation. Your watch would tick slower than a clock on Earth. A journey that feels like minutes to you could equal decades or centuries for everyone else. You would literally be traveling into their future. But time isn't the only thing that would get weird. Space would contort around you. The universe ahead would seem to shrink. This is length contraction. Light years could seem like a trip across town. To an outside observer, you'd look flattened, squashed along your motion. Space-time literally bends to accommodate such speeds. These effects are observable. Scientists confirmed time dilation with atomic clocks flown on jets and on satellites. Fast clocks tick slower than ground clocks, as Einstein predicted. Now we come to the biggest hurdle, the one that our current understanding of physics says is truly insurmountable. Mass and energy. E equals mc squared. Mass and energy are two sides of the same coin. As an object with mass speeds up, its kinetic energy increases, which in turn increases its effective mass, what we call relativistic mass. This increase is negligible at everyday speeds, but as you get closer and closer to the speed of light, it grows exponentially. Your body would become heavier and heavier, making it harder and harder to accelerate further. Imagine you are pushing a boulder. At first it's tough, but it moves. Now imagine that with every push, the boulder gets heavier. Soon it weighs as much as a mountain, and then as much as a planet. To get from 99% the speed of light to 99.9%, you need a massive amount of additional energy. To reach that final tiny fraction to hit 100%, the energy required becomes infinite. Your mass would also become infinite. It is the universe's way of saying, you shall not pass. Nuclear weapons technologies combined, multiplied many times over just to accelerate a single person to that speed. Our most powerful rocket engines, particle accelerators, are like flickering candles compared to the thermonuclear furnace required. Physics presents us with a wall of infinite energy, an absolute barrier protecting the cosmic speed limit from anything made of matter. This is not a technological problem solved by a better engine or fuel. It is a fundamental law of nature. Unless we discover a completely new kind of physics, mass energy velocity traveling at the speed of light will remain in the realm of imagination. It is a beautiful, inspiring dream, locked behind a door that requires an infinite key. The universe has set the rules of its own game, and this is one rule it seems unwilling to let us break. But let's be curious storytellers. Let's do what science fiction does best and ask, what if? What if we discovered a loophole? Imagine a future where we bypass these physical laws, perhaps by manipulating space-time with a warp drive, or traveling through a wormhole. In this world, running at light speed is possible. The traveler would become a glowing silhouette, a streak of pure energy cutting through the darkness of space. The hum of the universe would shift into a deep, resonant whoosh. Galaxies warp. Stars smear into long, brilliant lines of light, painting a celestial canvas unlike any we have ever seen. The implications for humanity would be profound. We could become a truly interstellar species, exploring distant star systems, potentially meeting other forms of life. A trip to our nearest stellar neighbor, Proxima Centauri, would no longer be a multi-generational journey, but a brief excursion. The vast, empty distances that separate the stars would shrink. The entire galaxy could become our backyard. We could witness the birth of new stars and the death of old ones, becoming cosmic tourists in a universe full of wonders currently beyond our reach. The sense of discovery would be limitless. However, this incredible power would also come with a deep and poignant danger, a profound sense of loss. Due to time dilation, every journey would be a one-way trip into the future. A traveler who takes a year-long voyage across the galaxy might return to an Earth that is thousands of years older. Everyone they knew, their friends, their family, their entire civilization, would be long gone, faded into the pages of history. They would become time-lost wanderers, forever disconnected from the world they once called home. The thrill of exploration would be forever shadowed by the melancholy of irreversible separation. This brings us to a final dramatic question, balancing promise against sacrifice. We dream of moving faster, of reaching farther, and of bending the rules of the cosmos to our will. Science gives us the limits, but our imagination pushes us to look beyond them, to dream of what could be. The desire to explore is etched into our DNA. As we stand at the precipice of such a monumental leap, we must ask a question that cuts to the core of what it means to be human. If we ever gained the ability to run at the speed of light, would we truly conquer time, or would we simply vanish into it? Beyond Universe, where imagination meets science. SFX. Gentle logo swell, soft chime.